tunnels. I will show you the fourth one. And this is what I found out, that as we look at the Sphinx.
Before the first visitors step onto the Giza Plateau, when the desert is still silent and the morning light is just beginning to spread across the sand, an ancient figure is already there, watching the world wake up. Carved from the natural limestone, its massive body stretches like a lion, while its human face looks east toward the horizon where the sun rises each morning. We know it as the Sphinx, and for generations, one question has followed it like a shadow. Who built it? Who looked at a giant ridge of pale limestone and decided to transform it into a colossal lion with a human face, then leave it staring toward the eastern horizon as if it were waiting for something? The explanation most of us learned in school seems simple. It has a pharaoh, a date, a dynasty, and a purpose. For more than a century, that explanation appeared solid enough to end the debate. Then something changed, not because archaeologists suddenly opened a forgotten tomb, not because someone discovered a hidden chamber beneath the desert. The shift came from something far less dramatic, and perhaps because of that, far more unsettling. An artificial intelligence was asked to examine the question. Not a historian whose career depended on a particular interpretation. Not a researcher defending a theory built over decades. Not an institution whose reputation was tied to an established timeline. And before we uncover what that machine found, subscribe to the channel, because what comes next could completely change the way you look at one of the world's oldest monuments. Because sometimes the most dangerous discoveries aren't the ones hidden beneath the sand. They're the ones hiding in plain sight. A machine. The system, built by Elon Musk's XAI, was presented with measurements and observations surrounding the monument, archaeological surveys, geological information, erosion patterns along its body, tool marks preserved in the limestone, the dimensions of the surrounding enclosure, its angles, its weathering, and the characteristics of the bedrock itself. The information was presented without the usual historical narrative attached to it. No conclusion was placed in front of the machine and asked to be defended. Instead, it was given a much simpler task: examine the evidence and determine what the evidence appears to be saying. And the response was not the comfortable answer found in the standard textbooks. It pointed somewhere else, somewhere older, somewhere far more unsettling, because if that interpretation were ever proven correct, the implications would go far beyond changing the date of a single monument. It would force us to reconsider the timeline we use to describe the earliest chapters of civilization itself. It would suggest that the story we have been telling about where our history begins may already be missing something enormous. Think about that before we continue, because everything that follows depends on one deeply uncomfortable possibility. What if a machine, free from professional reputation, personal pride, academic allegiance, or fear of overturning an established theory, can detect patterns in the stone that generations of humans have learned to overlook? To understand why that possibility matters, we first have to return to the beginning as conventional archaeology has traditionally presented it. The accepted story is remarkably simple. Approximately 4,500 years ago, during Egypt's fourth dynasty, Pharaoh Khafre was associated with the construction of the second Great Pyramid at Giza. According to the traditional interpretation, workers involved in that enormous building project carved the Sphinx from an existing limestone outcrop left standing within the quarry landscape. The face is commonly believed to represent Khafre himself. The body takes the form of a lion, an animal long associated with strength, authority, and royal power. Together, the figure served as a monumental guardian, positioned within the pharaoh's funerary complex and designed to endure for eternity. Half human, half beast, facing east, watching the sun rise over the horizon. The traditional timeline places its creation around 2,500 years before the birth of Christ, roughly the same broad period as the construction of the Great Pyramid complex, and the image is easy to understand. Thousands of laborers working with copper tools, wooden mallets, stone implements, and extraordinary patience, slowly transforming the desert floor into one of the most recognizable monuments ever created. That is the version of the story most people know. A pharaoh, a pyramid, a royal monument, a civilization at the height of its power, and a sphinx carved roughly 4,500 years ago. For generations, that was where the story began, and where the questions were supposed to end. And then the builders disappeared. The sand slowly returned, and century after century buried the monument until only its head remained visible. It is a simple story. It fits the accepted timeline, it fits the pyramids beside it, and it has been repeated so often that it feels like established fact. Khafre built it. End of story. But there is one problem with that explanation, and the more closely you examine the stone, the harder it becomes to ignore. Water. Look at the Sphinx's body and the walls of the deep enclosure surrounding it. The erosion doesn't look like what you would expect from thousands of years of desert wind and blowing sand. Instead, the limestone is covered with deep, rounded, vertical grooves and flowing channels. They look remarkably similar to the kind of erosion produced by prolonged rainfall. And that creates a serious problem for the traditional timeline. Giza has been a dry desert environment for thousands of years. The heavy, sustained rainfall capable of producing this kind of erosion is believed to belong to a much earlier, wetter period when the Sahara was green. If that interpretation is correct, the Sphinx could be far older than 4,500 years, possibly by thousands of years. That would place its origins in a time before Egypt had kings, cities, or anything resembling the organized civilization we associate with monumental construction. For decades, the idea was dismissed as fringe geology. One side pointed to the erosion patterns, the other pointed to the pharaoh and the accepted archaeological timeline. And the argument remained frozen until someone decided to approach the problem differently. Instead of asking researchers who already had theories, they gave the evidence to a machine. An AI system called Grok, developed by Elon Musk's XAI. It had no career to protect, no archaeological school to defend, and no established textbook answer it needed to preserve. It was given the data. And this time, the question was simple. What does the evidence actually say? Because once the numbers were allowed to speak for themselves, the answer became far more uncomfortable than anyone expected. What a machine could offer was something human expertise never fully could: complete detachment. It had no reputation at stake, no research funding to defend, and no decades of published work that might need to be reconsidered if the Sphinx proved older than expected. So they gave it everything they had. Erosion surveys, laser scans of the Sphinx and its enclosure, ancient climate records from the Sahara, rainfall models, limestone weathering data, even seismic measurements beneath the monument. No theory was given to defend, no date was suggested. The machine was simply told to examine the evidence, and it started with the erosion. Instead of relying on visual impressions, it measured the depth of the grooves, the shape of the rounded ridges, and the repeating patterns carved into the enclosure walls. Then, it compared those patterns against different causes of weathering. Wind-blown sand creates horizontal scouring. Salt leaves a rough, crumbling surface, but prolonged rainfall produces something different: deep, flowing channels that follow the path of water running down the stone. Grok compared the Sphinx's erosion against those signatures and produced a result that immediately raised eyebrows. The system reportedly gave the rainfall explanation a 94.7% confidence match, while the wind and sand explanations scored dramatically lower. But the bigger question was not what caused the erosion. It was how long did it take. The machine calculated how many years of heavy rainfall would be required to produce grooves that deep in limestone of that hardness. And when those calculations were compared with climate models of the Sahara's last major wet period, the timeline moved much further back. The analysis suggested that the stone had been exposed to substantial rainfall for centuries, during a period that ended thousands of years before the traditional date assigned to the Sphinx. That created a disturbing possibility. The monument would have needed to already exist while those ancient rains were still falling. In other words, the machine wasn't simply suggesting who might have built the Sphinx. It was challenging when it could have been built, and that date was far older than the one written in the textbooks. One engineer who examined the weathering evidence described the stone in a striking way. It was like a witness that could never lie. The limestone didn't know what historians expected it to say. It simply recorded every season of rain, every change in climate, and every period of exposure in the patterns left behind by erosion. And that record appeared to point toward a world much older than the traditional story. But this is where the mystery becomes much bigger than simply asking whether the Sphinx is older by a few thousand years. Because once Grok's analysis suggested that the body had survived the transition from a wetter, greener Sahara into the desert we know today, the machine turned its attention to another detail that had often been treated as nothing more than an artistic oddity: the head. Stand in front of the Sphinx and look carefully, and something immediately feels unusual. The body is massive, long, broad, and stretched across the enclosure like a gigantic reclining lion. But the human head, sitting on top, appears strangely small. For years, that imbalance has generally been explained as an artistic choice. Grok treated it differently. It measured the proportions. The volume of the head was compared with the enormous body beneath it, along with the proportions a sculptor would normally use when creating one unified figure. And the numbers revealed something difficult to ignore. The head is dramatically undersized. If the monument had originally been carved with more conventional proportions, the head would have needed to be much larger. That leads to a fascinating possibility. What if the head we see today isn't the original head? What if an earlier, much larger head once stood there and was later carved down and reshaped into the human face associated with a pharaoh? The machine wasn't claiming to recognize an ancient face. It was looking at geometry and weathering, and the weathering created another strange clue. The body displays those deep, flowing erosion channels associated with prolonged rainfall, but the head and neck appear to have a noticeably different weathering pattern, sharper and more consistent, with prolonged exposure to dry, wind-blown conditions. In other words, different sections of the same monument appear to carry evidence of different climates. And if that interpretation is correct, there is only one way to explain it. They may not have been carved at the same time. The body could have already been ancient, standing exposed to heavy rainfall thousands of years before someone returned to the monument and reshaped its head. The face, in that scenario, would not be the beginning of the Sphinx. It would be a renovation of something far older. It would mean the monument was not simply repaired, it was altered by people who may have encountered something already unimaginably ancient. One engineer reviewing the proportions explained why that matters. When you reshape a large stone figure into a smaller one, you cannot add material back. You can only cut away what already exists, so the smaller head may occupy the exact space left behind by an earlier, much larger form. In that interpretation, the pharaoh's face wasn't created from untouched stone. It was carved into the remains of something older, and when Grok reconstructed the missing volume, the proportions reportedly produced something unexpected. Not a human head, but a lion's head, a complete leonine figure, with the head properly scaled to the enormous body beneath it. But then, the machine asked an even bigger question. When would a lion have mattered astronomically? Because ancient builders often aligned monuments with the sky. The Sphinx faces almost directly east, toward the point where the sun rises around the spring equinox. So Grok turned to the ancient sky and asked, what constellation occupied that eastern horizon during the monument's possible age? The answer lies in the slow movement known as precession. Earth's orientation changes gradually, shifting the position of the constellations over thousands of years. When the sky was rewound, the analysis pointed toward a period roughly between 10,500 and 8,000 years ago, an era when the constellation Leo was positioned along that equinoctial horizon. A lion on Earth facing a lion in the sky. If intentional, that would mean the Sphinx wasn't simply a sculpture. It could have been an astronomical marker, tied to a specific period in the ancient sky thousands of years before the pharaohs. And that raises an even bigger question. If the Sphinx was marking a particular moment in the heavens, what else was marking the same moment? So the investigation moved beyond the monument itself. Researchers had long reported unusual underground readings around the Sphinx enclosure, possible cavities, voids, and formations that some interpreted as natural fractures or later structures. But Grok compared their positions with the astronomical alignment it had already identified. One anomaly reportedly appeared to sit almost directly along the same eastward axis, beneath and ahead of the monument, almost as if the alignment in the sky had been reflected beneath the ground. And suddenly, the mystery was no longer only about what the Sphinx looked like. It was about what might be hidden beneath it and why it was placed there. Then Grok widened the map, and that was when the mystery became much larger than Giza, because the Sphinx wasn't the only ancient monument aligned toward the rising sun. Across different continents, civilizations separated by oceans and thousands of years also built structures around the movements of the sun and stars. Grok placed those sites together and began measuring the relationships between them. What emerged, according to the analysis, wasn't random noise. It looked like a network. Similar angles, repeated proportions, and astronomical orientations appeared across places that supposedly had no contact with one another. The map included sites such as an ancient hilltop complex buried roughly 11,000 years ago, long before writing or agriculture, enormous stone terraces in the Andes, and circles of standing stones positioned to track the changing sun. Different continents, different cultures, different eras, yet the geometry appeared to repeat. One engineer reviewing the results said the unsettling part wasn't a single alignment, it was the redundancy. One monument facing the sunrise could be coincidence. Two might still be coincidence. But if numerous sites share similar solar targets, proportions, and relationships with the stars, the pattern becomes much harder to dismiss. It begins to resemble a template, and if there was a template, then someone, or some earlier tradition, may have created the original design. But then came the strangest discovery. Grok compared the precision of these structures across time, expecting the normal story of human progress. Rough beginnings followed by increasingly sophisticated engineering. Instead, the data appeared to point in the opposite direction. Some of the oldest structures were among the most precisely aligned. Their stone joints were remarkably tight. Their surfaces were carefully engineered. Their astronomical orientations were exceptionally accurate. Later structures often showed more variation, weaker precision, and greater deviation. The knowledge wasn't steadily improving. It appeared to be disappearing. Generation after generation may have preserved the shapes without fully understanding the mathematics behind them. Grok summarized the pattern in a chilling conclusion. The precision curve was inverted. The builders weren't learning, they were forgetting. And if that pattern is real, then Giza, the Sphinx, and other ancient monuments may not represent the beginning of civilization's greatest achievements. They may represent the final echoes of something much older. A knowledge system that had already begun fading 10,000 or even 12,000 years ago. We have always imagined history as a climb, from primitive beginnings to an ever-advancing civilization. But what if we've got the direction wrong? What if we're not witnessing the rise of civilization, but its recovery? What if an earlier civilization reached a level of knowledge we are only now beginning to rediscover? And perhaps that's why these ancient monuments feel so mysterious. We may have forgotten that they were never meant to be mysteries. They may have been messages. The machine's analysis keeps pointing back to roughly 12,000 years ago, a period of massive climate change, rising seas, retreating ice, and a world transformed almost beyond recognition. Whatever came before may have been buried by water, sediment, and time. Yet on the other side of that catastrophe, these monuments remain. Stone, angles, stars, a lion facing the dawn, structures aligned with the equinox, patterns repeated across distant parts of the world, almost as if someone was saying, "We were here, we understood, remember us." But what were they warning us about? The machine could find the patterns, but it couldn't understand the message behind them. And maybe that's the most unsettling part, because the possibility remains that something existed before the civilization we call the beginning, and that we are only now rediscovering fragments of its knowledge. The Sphinx is still there, staring toward the same horizon it has watched for thousands of years. It never hid its story. We simply didn't know how to read it. So what do you think? If the Sphinx really was connected to the age of Leo, what was its ancient clock measuring? Was it a memorial to a lost civilization, or a warning about something yet to come? Tell me your theory in the comments, and if you want to see what happens when the machine examines the next ancient mystery, subscribe to the channel and tell me which site we should investigate next. Because the lion has been watching the horizon for a very long time. Maybe we've only just learned where to look.